So we need to talk about robustness again. We did this in chapter 20, but let's revisit it now that we're working in two sample T procedures. So two sample T procedures are more robust than the one sample T methods, particularly when our distributions are not symmetric, right? When the size of our two samples are equal and the two populations being compared have distributions with similar shapes, the probability values from the t-table are quite accurate from a broad range of distributions, even when our sample sizes are really small, which is kind of shocking. When the two population distributions have different shapes, we're definitely going to need a larger sample. Again, I feel like 5, right? If you knew that 5 people participated in a study, you'd feel like gut instinct, like, oh, that's too small, right? So keep that in mind as well. As a guide, adapt the guidelines for the one sample T procedure to two sample T procedures by replacing sample size with the sum of the sample sizes. But be careful, because when you're planning a two sample study, you need to choose equal sample sizes whenever possible. The two sample T procedures are the most robust against non-normality in this case, and the conservative option 2 from our table are going to be the most accurate. Okay, so a few more details about the T distribution. So the exact distribution of the two sample T statistic is not a T distribution. It changes as the unknown population standard deviations change, but a really good approximation is variable. So we can approximate the distribution of a two sample T statistic with degrees of freedom. This is the one that's given to you by technology. I don't expect you to calculate this by hand. Would be our sample standard deviation squared over its sample size plus the sample standard deviation squared over its sample size squared. So we're squaring things twice over 1 over the degrees of freedom of sample 1 times the sample standard deviation of the first one squared over the size of the first sample plus 1 over the degrees of freedom for our second sample size times our second sample standard deviation squared over its sample size squared. And this approximation is accurate as long as n is 5 or larger, as we talked about on the previous page. I want you to note that many calculators often offer a two sample T statistic. It's often labeled for unequal and one for equal variances. The unequal variance produces our two sample T, right? But we want to never use pooled T procedures if you have software that will implement the unpooled variance procedure. We also need to avoid inference about our standard deviations. So there are methods for inference about standard deviations on normal populations. The most common being like an F-test. We're going to see that in chapter 27 for comparing the standard deviations of two normal populations. Unlike our T procedures, the F-test for standard deviations is extremely sensitive to non-normal distributions, like really, really sensitive. So we do not recommend trying to make inference about population standard deviations in basic statistical practice. That's why we really only look at means.